Hi there, welcome back. Sorry about the little delay there. We just had a few technical things. We were plugging in phones and screens and all kinds of stuff. Anyway, just a question before I introduce Liz. A question that came from the last session, talking about those VMs you can download with all the tools on it. The question is, well, the comment is, I'm pretty sure that you will not be able to run the mobile device emulator in VMware or VirtualBox or Hyper-V. Yeah, that's a good observation. That is the kind of the downside, if you like. But you can use, a real phone. You get a real phone, plug it in with a USB cable, and so you can still work with those devices. But yeah, that's a good point. Anyway, thanks for that. Now we showed a bit of an intro of Continuum in the last session, and now I'm really happy to have Liz Threlkeld with me. Liz, you've written a fantastic blog post on all of this stuff, and you work on the team?
Yes, I'm a program manager on the Continuum team, and as Andy said, we just posted a blog yesterday or a couple days ago, and some of this content was covered at Build, but we have a couple of updates that we hope will be useful for you guys as you think about developing and optimizing on Continuum.
Cool, cool.
So Andy dragged me in today, so we'll just kind of go through some of the stuff that you as developers should be thinking about when you're optimizing apps for Continuum. But first we want to kind of pause and give a brief overview of what Continuum actually is for those of you who might not be familiar with it. Generally, Continuum is all about being able to take your phone, your mobile device, and plug it into any external display and run two apps simultaneously. One on that external display that's scaled to look beautiful on that screen, and then one also on the phone. So you can use your phone like a PC and like a phone at the same time. The beauty of Windows apps, your universal Windows apps, is that if you build universal Windows apps, they should just transition seamlessly between screens without you having to do any additional work, which we'll touch on more in a bit.
Yeah.
And then finally, users can use your apps with keyboard and mouse on the external screen, much like a desktop machine instead of a phone. So I think before we dig into all of that, here is a short video that's kind of an introduction to Continuum. And you can find this on the web, but we'll go ahead and play it now.
So I thought it was nice because that kind of really illustrates the kind of flexibility of it. And actually, when you start to use it, you think, you realize this is not just a cute party trick. This actually is really useful.
Yes, definitely. Yes.
And that showed the two scenarios. We're using a wired dock here, and that's kind of fine for a desk, isn't it? A home sort of worker and that sort of thing, where your phone can double up as these phones have got phenomenally powerful processors, you know. So
yes,
you've got all that power we can take use of.
Yes, definitely.
And then, but in the living room, they were kind of using it wirelessly with a wireless dongle, and that's kind of real nice. Gets rid of the clutter of the cables, and is really good for a kind of home environment.
Yeah. So we'll talk about a couple of scenarios. I'll just skip to them right now, actually, and then I'll give you guys a real demo of our setup today. But yeah, as Andy was just saying, there's kind of three main hardware configurations. The first one is a wired dock, and this is actually, we have it here in the studio. I don't know if you guys can see this. I hope so. And basically, this dock allows you to plug your phone in with just a USB Type-C cable into the dock, and then plug the dock straight with an HDMI cable into any screen and power a productivity-like experience. The dock also has USB ports, so you can plug in USB keyboard and mouse just like you would on your desktop machine. And I can use those today to be productive with my phone. There's also two other kind of configurations. One is a wireless dock. So there's Action Tech builds a great wireless dongle that actually has a USB port as well, where you can connect wirelessly to any screen and then plug the USB port in for keyboard and mouse. And finally, this is also kind of highlighted in the video. There's a wireless dongle where you can plug it into, say, a TV and then use a hands-free mode to really be able to relax and sit back and watch videos or browse the
Those wireless dongles, they kind of plug into an HDMI input and then usually have a USB to power it.
Yes, exactly. Yeah. Yep. So I think I'll actually skip over and show you kind of a demo just to get a little bit more grounded. And so if we will switch, we'll see if this technology will work with us here. We'll switch over to the phone.
Bit of a pause. It's kind of a little bit, this HDMI switch is a little bit temperamental.
Quite temperamental. Oh, there we go.
Oh, yeah.
Oh, there we go. Lovely, we got it. So, as you can see on this larger display, I have, the first thing you see is my start screen, and that is just my start screen for my phone with the same tiles I'm used to, same live tiles. And when I'm on this display, I can actually go ahead and launch any of these apps. And when I launch these apps, because they're universal Windows apps, they will actually scale to take advantage of this external display. Now, again, I think Andy covered this in the last session, but this TV is kind of letterboxing the display weirdly.
Yes,
I think it's just like an old TV or something. Normally, it would take full advantage of this display and look just like a PC would. But you can see that, say, the Outlook app actually scales really nicely and reflows to the big screen. That's because they're using the basic adaptive principles that we've been talking about in many Windows kind of blogs and videos.
Yeah.
And just to kind of highlight a couple more scenarios, let's say I needed to write a Word document. Well, Office has also built adaptive apps, and I can go ahead, I can open Word. Sorry, I got to go through Word Ubi. And whenever I launch Word, you'll see that this is just like it would look on the desktop. It's the full experience, exactly. And that's just because they built on the Universal Windows platform, and their app is adaptive and scales to the screen. And I think the other good thing to point out is if we can get a view on the phone up here, great, then you can see that my phone is still just behaving like my phone. I have my start screen, I can scroll around, I can launch different apps here. You can see I just launched Edge, and I can scroll down and see what's going on. And so this is great because while I'm using the big screen to be productive, I can also use the small screen to send messages or talk to people or make phone calls, etc.
Cool. Yeah.
Cool. So we'll switch back to some slides and dig into what this means for the developers that are watching.
You have to point at the right point. Here we go.
Excellent. Okay, so I think based on those hardware configurations, everything, the first kind of thing to keep in mind as a developer when you're thinking about Continuum is that users will use adaptive apps that you write, Windows apps, on the big screen, and they'll be using keyboard and mouse primarily to interact with them. So developers who kind of come from a mobile-only mindset should kind of think about shifting how you think about your app that will run on Windows Mobile, because now with Continuum, Windows Mobile will bring apps to any screen size with any form of input, at least keyboard and mouse for now.
Cool.
So whenever you're thinking about Continuum, there's a handful of considerations you should think about, but the most important one is just building an adaptive app. And there's nothing special you really need to do for Continuum. It's exactly the same adaptive principles and techniques that you use to build your app for mobile and desktop today. And if you use adaptive techniques that are available today, your app should just work and light up great on Continuum. So really, for Continuum, the connected screen is just another screen size. The phone is a display with some screen size, and then the connected display is just a different screen size. And if your app can adapt based on screen size, then your app should be able to adapt in this scenario just fine.
Yeah, yeah. It's probably worth mentioning, isn't it, that actually if you've got 8.1 apps on the phone, they won't work on the connected screen.
That is true.
So you need to, this is a good excuse if you were looking for one, to upgrade your 8.1 apps to UWP, and you can get them running on the big connected screen.
Yes, that is definitely
And on
true.
the desktop. And, you know, what are you waiting for? Just go, let's do it.
Yeah, and if you're going to optimize, do any sort of optimizations for Continuum, and you have a mobile app only, it's a good excuse, to go ahead and build a fully universal app and target all Windows device families.
Yeah.
And so, as we said, you can use the same adaptive triggers that you're already using to make sure that your app scales and adapts to the big screen. In this example, we have basically a button where on big screens you might want to show the button in a wide view, where on small screens you might want to have a narrower button because of just the screen real estate. So here you can see on the internal screen, which is the phone, basically if the min width is anywhere from 0 to 800, you would show the narrow button. Whereas on the connected screen, you would show a wider button. And this is just using the min-width window adaptive trigger that's available today.
So there's nothing unusual. It's all standard adaptive UI stuff. Yeah.
Right, exactly.
Yeah.
A new thing that's actually available to mobile in Threshold is the User Interaction Mode API. And this API is another tool that you can use to make sure that your app adapts well across screens. It's not an adaptive trigger per se, but it's another tool for you to leverage. And so this API gives you context about the screen that your app is running on. And it returns one of two values. It either returns touch or mouse to describe whether or not you're on a Windows shell optimized for touch or a Windows shell optimized for mouse. And so in Continuum, if we look here, whenever the user interaction mode returns mouse, this means that your app is running on a mouse-optimized shell, which in Continuum means you're on the connected display, which we always return mouse for because we expect it to be a very productivity-first, PC-like, mouse-first experience.
Yeah. And I guess this is for those who want to go the extra mile about creating an adaptive UI that is highly optimized for the interaction mode, which is a good thing to do, but it's not mandatory. But
correct.
But it is going to be a subtle difference, I guess, between a desktop view running for touch, which is where you would want to kind of make the hit targets a bit bigger, space things out so that it's really easy to interact with a finger, compared to, actually, you can pack things a little bit closer together when it's running on a connected screen, because that will be mouse.
Yes, definitely, definitely. And so this will allow you to tailor your app in those ways. And on Continuum, the external screen will always have a return of mouse, and the internal screen or the phone will always be a touch device.
Yep, great, okay.
I see a question about the RT version of Office on Continuum.
So yeah, really UWP has supplanted that. Yeah, so UWP,
exactly.
UWP apps run across all of the ARM. We've got ARM processor in these.
Right.
We've got x86 and x64 on desktop. So, the new modern version of Office is optimized for all of these different use cases.
It is, exactly.
So, yeah, so that's really, the older, the RT version is not something that is applicable really to this.
Right. We want to use the new modern apps that are adaptive and have all of the new modern Office tools.
And we are continually updating them, so
of
they're getting revised all the time. You get more and more new features.
Of course.
Yeah. So just to follow on from all that, I just wanted to revisit the app that I showed in the first session, which was the to-do one, which is, it's a nice example of adaptive UI, just to illustrate that there's really nothing different going on here. So let's go and find that particular one. And if you remember this one on a big screen, well, let's do it on the desktop first, which we don't want ARM for that, we want x86. And running that on a desktop, we will get, it still has that adaptive UI. We can, because when we're running in desktop mode anyway, windows are resizable by the user, so you want to create an adaptive UI that's going to work well to a sort of a narrow phone-sized UI like this. Or you can expand it out and we get the bigger experience where you get a sort of inline editing. So when it's in a kind of compressed form, like that, in order to edit one, it's a kind of a page thing, whereas when you expand out, you get everything all on one screen. So it's a nicely optimized adaptive UI. And when we're running on the internal screen, you're basically, I showed this in the first session, you've essentially got that view as being the primary. This is exactly the same experience as you get on the integral screen.
On the phone, right?
Yep, on the phone. and then obviously on the connected screen we have this one. So this is really there's nothing unusual about the UI for this. So just stop that and let's have a look at some of the files in this. Here's Solution Explorer. So the main views here. Let's have a look at the main page.xaml. Has got inside it. I've got a weird box turned up. Go away. What is that?
No, just click that button.
Oh yeah. Go away. Thank you. So just loading the designer, and there we go. You can see the view. It's not very big. Get that up a bit bigger. This is the 10.2.40 sample. The Continuum doesn't change anything. This is just the same as it ever was. And if we start digging into the UI for this, the XAML defining it, you'll see we've got these visual state. We've got a single visual state group, and inside it we've got a number of visual states. And for the adaptive trigger min width of 1, so this is the narrow one that's going to end up on the integral screen of the phone. Well, we're doing things like the inline to-do item view grid. That's the editor on the right of the screen. That is a value of collapsed. So that's hidden in this view. It has a background that's also collapsed, and we changed some grid column spans for the main list view, so it's spanning across a couple of grids. Get out a bit bigger. So this one is a min window width of 800. So this is when you start getting out to the medium. And actual fact, the attached screen will either fall into this 800 or into this 1200.
Yeah, I think it's generally safe to assume that the attached screen will be greater than 800 of a min width, and it's up to you to decide if you want more triggers at more min widths or just one or two.
Right. And in fact, this one has no visual state setters at all. So you're getting the default experience that we've designed, which is the default one is the one we are seeing there in the designer. So that is the wide view that we get, whereas when we get into a narrow one, this is the inline editor that gets hidden, the background gets hidden, and we change the grid there to be spanning the two columns. It's standard, absolutely standard adaptive UI stuff.
Yeah, and so if you've gone through the effort to make this adapt on a desktop machine, then you should get all of this behavior for free on Continuum.
You get it all for free, yeah.
Awesome. So one last point, or I want to make a couple more points. We have one question that says, can I use the same app on the phone and the external screen simultaneously? Today you can't. Basically, the app will either be launched on the phone or the external screen. And if you launch it, say, on the phone first, and then the user goes ahead and launches it on the external screen, it will actually move the app over to that new screen.
And that's the same experience as having a desktop with a dual monitor setup. And
exactly.
Really, it's the same thing.
It's very similar.
Yeah.
And when you do that, all that will happen to you as a developer is you'll get a window resize event, and just like you would on a desktop if the user had resized your window.
And your adaptive triggers will kick in, and you'll get the right UI experience. Yeah.
Exactly. So I guess continuing on, if you create separate pages for different screens. So let's say you have a separate page for your phone view and one for the desktop or your large screen.
So yeah, we've seen a few samples, because not having one page that adapts to every scenario, that's good for a lot of apps, but not everybody wants that.
Some people actually want different pages, right?
And sometimes if you just want to think in a kind of a more direct way. Oh, I want to think about my phone, a narrow screen layout, and I want to put that in a separate page. I don't want to do all this adaptive UI stuff. But you have to be a bit careful with that, don't you?
Yes, you do. I've seen a lot of samples on the web and a lot of posts about people who are switching between pages based on device family, which for most scenarios works great, but for Continuum, if you are basing whether or not you show kind of a mobile page based on if you're on a mobile device or not, then you'll actually wind up with only getting your mobile page on Continuum, whereas you would probably want to get your desktop page on Continuum. And that's because the second display on Continuum is still being powered by a mobile device, so it will still look like it's part of the mobile device family.
You could ask, you can find out what device family you're running on, and it will still tell you mobile, despite the fact we're onto a big screen.
So we recommend that instead of switching based on device family, that you actually switch based on either screen width or even physical screen size. And so going back to an example that Andy had talked about in the previous session, there is this new property of the Display Information API that allows you to get the actual physical diagonal size of a screen in inches. And you can use this to actually switch between, say, showing a one-handed view or a desktop view, rather than ever using device family in this case.
Yeah, cool.
So, I guess to summarize that part of it, the most important thing you can do to work great on Continuum is build an adaptive app. And I'll go through a few more considerations for you now, but that one is really kind of the most important to your success. So just a couple of points on how to think about packaging your Windows apps. Kind of in summary, if you build an adaptive Windows app and it's available on Windows 10 Mobile, it will work on Continuum by default.
Yeah, because you can, at the store submission stage, you can say, okay, this is just a desktop app, or this is just a mobile app, and you can put some stuff in the manifest to restrict it. But yeah, as long as you make it available on mobile, then you're good to go.
Then you're good to go. I think the thing to watch out for in terms of packaging is if you have, say, two separate app packages, one targeted at only the mobile device family and one targeted separately at the desktop or desktop device family, then you won't get any of the kind of desktop work that you did on Continuum by default. You actually need to deploy code to mobile that will have the large screen view and adaptive properties that you want.
So yeah, question. How would a UWP app adapt to an 84-inch screen? Well, that's just another screen.
It's just another screen?
It's a design exercise for you to figure out how you would want to lay out. Maybe a to-do app might be a little bit lost on a screen that size, but
might need some more columns or something.
I think we might need to actually maybe have a couple of instead of having a single list view, maybe we span it out to a couple, or you can let your creative imagination run wild on that one. You've got a lot of screen display area there, so if you
it's
can
totally up to you. And I mean, you'll be able to understand if that screen is 84 inches, and you'll know the effective width and height of that screen. And you can make your buttons bigger. You can add more columns. You can just let your creative juices flow, as Andy said.
Yeah, that's right. Yeah.
Okay, so I think one other kind of point I want to touch on for packaging is, what if your app's not quite ready for Continuum yet? Let's say you built a mobile app and you haven't had time to really optimize it for the big screen, but you want to. You can actually go through the work to opt out of your app running on the connected display by just kind of making these changes to the app package and then setting this true-false state. And basically this will either restrict your app to the internal screen or the phone, or it won't.
Yeah, and this is a manual edit. You have to edit the
yes,
go in and edit.
You have to go ahead and edit the manifest.
Manifest, yeah.
And so if you do this, basically your app on the external display will show up as a grayed out tile in the start screen and the all apps list. Yeah. Until you actually go back and change this value to be false instead of true.
Yeah, yeah. We just had another question. So from Ricardo, can I have different view settings, so like different backgrounds to my views, whether it's on the main screen or on the connected screen? And yeah,
it's totally up to you.
Totally, because although the examples we've tended to show, you're switching on the screen size, so that's how the adaptive triggers are figuring out which screen size you're displaying on. And we have been moving things, we've been hiding stuff, but absolutely, you can change colors in there. You could change font sizes. You can make anything.
You can change whatever
you want in those. So within your adaptive triggers, if you want to have a different background color for the different views, absolutely go for it.
Yep,
go for
definitely.
It. Yeah, and actually this adaptive UI stuff. If you go back to the developer's guide to Windows 10, the RTM version, the build 10.240 that we did a whole hour on adaptive UI where we did a deep dive. And I know you in the build session, you did quite a lot on the adaptive UI as well in the recording of that. So there's plenty of great resources out there to learn a bit more. If you're kind of new to this adaptive UI, it's not just about screen sizes. You can
build all kinds of custom triggers. So we encourage you to go look at those.
Yep.
Okay, so one kind of other thing to think about is how your app say, individual assets or glyphs or pictures in your app actually scale across all these different screen sizes powered by a phone. And I just want to precurse this by saying that it's not a requirement for you to think about this. This is something you should think about if you want your app to be pixel perfect on every screen. Yeah. But if you don't do it, your app it'll look pretty good.
This is people who want to go the extra mile.
Exactly. Think about how their apps look on a big screen. So today in Windows, every display has a specific scale associated with it. And in general, when we think about Continuum, the phone generally has a scale somewhere between 200 and 400. Monitors generally have a scale of 100, and TVs generally have a scale of 150. And this varies based on the device. Like a 4K monitor might have a different scale than the average monitor. But this is a kind of a safe assumption for now on Continuum. And I think the biggest problem that you could run into if you don't provide additional scaling assets for these scale 100 and scale 150 screens would be downscaling. So let's say that all you as a developer have done is provide scale 400 like icons or glyphs for your app because you really optimized it for a specific phone. Now, whenever your app is moved to an external display, the system will actually go ahead and compress the available assets down to a scale 100.
Just scales them down.
Just scales them down, yeah.
If you want to, you can just supply one scale resolution. The system will just take care of resizing it.
Exactly. Yeah. And when the system does this, the risk that you run is that they might be a little bit blurry. And I mean, I'm pretty sure you guys won't be able to see that through the screen.
But if you look very carefully, this one. You know, if you're a real perfectionist, you would say, "Oh yeah, definitely, have to go for that one."
Yes. Yeah. So, if you want to have that pixel perfect, very crisp view, then you should go ahead and provide those assets.
But what you said before is like most apps, it'll be good enough.
It will be.
So, but
realistically,
we love to encourage perfection, so go for that.
Yep. So here's a couple of ways you can go ahead and add those scale resources. The first is you could add additional scale resources into your assets folder in your solution with scale-XXX notation. So you can see here that I have 4 different variations of my logo, and I have them for .scale 100, .scale 150, etc. And then I could also add them in this format to my solution where I actually have scale 100 folder, scale 150 folder, and then I have the same list of assets in each of those folders.
It's very flexible, isn't it? This modern resource technology. You can have it in the name, or you can actually have it in the path, effectively.
Exactly, exactly. And so the beauty of this is that whenever you organize your assets like this, all you have to do is reference the asset with a URI, completely leaving off the scale XXX notation, because the system will be able to go through all of the available assets and pick whatever the best ones are for a given display. And just another example of what this could look like, an image tag example. So we have a couple questions. Does Continuum support a higher resolution than 1920 by 1080? Might look a bit low res on an 84-inch 4K monitor. So we support a whole slew of resolutions. 4K is one of them. So it should look fine on those displays. In general. Another question: can we resize the video dynamically versus refresh rate, meaning giving the users options? Yeah, you should be able to resize the video dynamically. It's kind of up to you as a developer to make sure that you continue resizing and playing the video based on, or whenever your app is resizing.
Yep.
There was talk of a gesture to flick an app from the phone to the big screen. So today that's actually a great segue. Today there's not a system level way to do that, but we are about to talk about how you as a developer can build multi-screen experiences where you might be able to build gestures like that into your own app.
Yeah. So the APIs are there, but there's nothing system provided.
Right, exactly. Okay, so
on that subject.
We'll go ahead and talk about the multi-screen APIs that are available today. So you as a developer can actually take advantage of the phone and the connected display simultaneously in this situation. And kind of the first API that's available is the Cast API. And this API is really meant for developers who have media apps who just want to literally take a video from their app on the phone and put it on the external screen. And so it's really, really easy for you to do that with the Cast API. You just feed the media element to the system, and we kind of do the work for you to get it up to that screen and play it. And then your app actually just stays on the phone minus that media element. And the second API that's available is the Projection Manager API. And this API actually allows you to have full control over both the view on the phone and the view on the external display, as well as the interaction between those two views. So PowerPoint is a really great example. I'll actually show you guys this working in real code. But PowerPoint has built this view where you have basically a notes view and kind of preview of your slide on the phone while you're presenting. And then all the user sees is kind of that slideshow view. But
yeah, cool. And it's worth mentioning both these, the cast and projection manager. If you go off to GitHub to our Windows Universal samples, there's examples of using those APIs up on there. So, yeah.
And no, this is obviously not just a phone Continuum specific API. This will work on a desktop machine in exactly the same way.
Yeah.
So here's a little example of how you could leverage the projection manager. You start by checking whether there's an active connection to an external display. If you find out that there is, you can actually create the page in the view that you want to project. And then when you're ready, you call start projection async to actually begin displaying that view on the connected display. And when you're done, you call stop projection async, and that will end the projected session.
It's pretty straightforward.
It's very straightforward.
Yeah.
So I want to end by actually showing you guys PowerPoint working in action. Oh, which actually might not work on your phone. It might not work on your phone.
You think so?
Yeah, because you're not logged into the right
Oh,
account.
yeah, that's right. Yes.
So we'll see if we can get
See if
this
we get
phone to work.
working.
If not, nope.
That's too bad.
Okay, technical difficulties.
Yeah, so you were saying that actually that features a premium.
That feature, so that, yeah, so we're having some technical difficulties here, but that feature is a premium feature, so you have to have an O365 account to actually be able to use it, which
this one is not
Andy
set up
unfortunately is not set up for. So,
yeah.
But if you go and check out the build talk that we did on Continuum at last year's build conference, you'll actually be able to see a preview of PowerPoint using that API.
Right, yeah. There's a couple of questions. Where can I find a complete set of sample icons for a UWP app? Well, such a thing doesn't really exist.
Doesn't really exist.
No. Again, if you look at some of the other early developers guide videos, there's a whole font set, Seago MDL2 assets, which is a font which has lots of nice little icons for button icons and that kind of example. So have a look at the Seago MDL2 font. That's the best example I can think of getting the UWP styled icons. That's what we tend to use if we're putting icons into any of the
Yeah, and the
UI.
nice thing about fonts like that is that they actually scale automatically across screens. The app frameworks actually do work to scale fonts for you, so you don't actually have to worry about including additional icons or anything like that.
That's right.
Yeah.
Another one, is there a bigger latency when it's running on a connected display compared to when it's running on the integral?
So it really depends on the situation. Sometimes, depending on what apps you have running and how many apps you have running, latency is not really an issue. But if you, say, go open 10 Edge tabs and have videos playing and are trying to process some data in Excel, then yeah, you'll notice some latency.
Yeah.
And I think that's really due to limitations in having a phone as a form factor, just not being able to dissipate heat as quickly, say, as a laptop, even though it has the right processing power for that latency.
Yep, yeah. Sure. Yeah. Right. Good. So that was the non-existent demo.
The non-existent demo.
Yeah.
Go check out the build talk.
Yeah. But that's it. So I guess the message here is, like, unless you want to do the multi-screen thing, which is a specific edge case for certain apps.
Right.
The general case is just adaptive UI.
Build adaptive UI, and you should get a lot of free benefits on Continuum.
Right. Yeah, great. Yeah. All right, well, thanks ever so much, Liz, for your time.
Thank you, Andy.
Thanks for joining, and thanks for watching. We're going to take a short break. In fact, I'm going to give way as well. We've got Paul and we've got the composition UI team going to come in, show you this great